GrimAge is the best epigenetic clock for evaluating risk of death. And if you missed that video, I'll link to it in the right corner. But for now, which biomarkers are included in GrimAge? That's what we'll see here. So first, it includes age, gender, and an epigenetic approximation of smoking, DNA, and pack years. And then GrimAge version 1, which is shown here. GrimAge version 2 actually includes a couple of additional biomarkers or epigenetic approximations of additional biomarkers, including hsCRP and HbA1c. But for now, I'm only focused on GrimAge version 1. It includes 7 protein biomarkers that may be obscure to many. Actually, it's an epigenetic approximation of those 7 biomarkers. So the first may not be obscure to many who are frequent viewers of the channel, and for that, thank you. It's epigenetic approximation of cystatin C, which is a biomarker of kidney function, but as we'll see in a future video, it's also associated with a biomarker of neurodegeneration. Then also, we've got leptin, which may seem familiar to many, but then others that are very obscure. TIMP1, PAI1, GDF15, ADM, and the biomarker that I'm going to focus on in this video, B2M. B2M stands for Beta-2-Microglobulin, which then raises the question of, besides contributing to GrimAge, why is B2M important? The beginning of that story will be illustrated by this paper shown here, where B2M was identified as a systemic pro-aging factor that impairs cognitive function and neurogenesis. That then raises the question of what's optimal or what may be optimal for B2M. I won't show those data in this video, but it increases during aging, and higher levels are associated with an increased all-cause mortality risk. In terms of what's optimal, I have a new Patreon tier dedicated specifically to what's optimal for biomarkers, which now includes B2M, which we can classify not just as a kidney function biomarker, but also we can identify it as an immune-related biomarker, and as we'll see in a minute, it's related to neurogenesis. Besides B2M, this tier currently includes 35 other biomarkers, almost 2.5 hours of video content, 57 published references, and note that these aren't the reference ranges which you can get from any LLM these days. This is my interpretation of what may be optimal based on how each of these biomarkers changes during aging and or associations with all-cause mortality risk in the largest studies that exist. So if you're interested in that, check it out. In terms of the data from this paper, let's focus on B2M's impact on neurogenesis. First, starting off with the data here. On the y-axis, we've got double cortin number of cells /DG. So this is the number of double cortin expressing cells, which is a neurogenesis biomarker, as I'll show in a minute, in the dentate gyrus, which is a portion of the brain. And in terms of double cortin being identified as a neurogenesis biomarker, we'll see that story here. So neurogenesis proceeds along a spectrum, from quiescent neural stem cells on the left to mature neurons on the right. And we can see that there's a cell type as identified there that expresses double cortin or DCX positive cells. So double cortin is well known as a biomarker of neurogenesis. So back to the data on the right, where they compared double cortin expressing cells in mice that were treated with B2M for 12 days. And what we can see is that the neurogenesis biomarker double cortin declined by about 20% in just 12 days after exposure, after mice were exposed to B2M. So relatively high levels of B2M impair neurogenesis. And I should also mention that that's important because neurogenesis declines during aging. So when considering that B2M increases during aging, are they causally linked? I'm not sure about the data in people, but this is an association that is not potentially good news. But this is just one part of the story. What happens if we remove B2M? So if adding it is bad for neurogenesis, if we remove B2M, we'd expect that to be good for neurogenesis. And that's what they tested in this study. Again, on the y-axis, we've got double cortin expressing cells, so this neurogenesis biomarker. And now we've got B2M minus mice. So these are B2M knockout mice. In other words, they knocked out the B2M protein so that these mice didn't have B2M. And note that this is a longitudinal study as these mice were 18 months old. So this is an 18-month study of evaluating the effect of B2M on neurogenesis. When compared with the data in aged wild-type mice, which have normal levels of B2M, we can see that the mice that were genetically engineered to not have B2M had more than 2 times higher levels of this neurogenesis biomarker double cortin. So collectively, these data implicate relatively high levels of B2M, especially as it occurs during the aging process, as potentially being bad for neurogenesis in people. But could that be true? As I mentioned, these data are in mice. What do the data look like in people? So that's what we can see here, where we're going to look at B2M levels in brains of people who were controls, who were not diagnosed with Alzheimer's disease, AD, and in people who had Alzheimer's disease, AD. And note that this is a post-mortem study, so unfortunately the people had died and they biopsied the brains afterwards and then quantified the amount of B2M that was in those brains. And what we can see is that people who were diagnosed with Alzheimer's disease had 2 times higher levels of B2M in the brain, which again is potentially bad news. So with that in mind, what's my data? This isn't just a health and longevity news channel. As I've said this many times, this is also a health and longevity optimization channel. So what's my data? So I currently have 6 tests for B2M. As I mentioned, I just started measuring it in 2025. And as a quick aside, why I just started to measure this now, after realizing that I'd rather have the actual biomarkers rather than their epigenetic prediction as found in GrimAge, and knowing that B2M is one of the biomarkers, the actual biomarkers that GrimAge is based on, I started measuring B2M in 2025. I wish I'd measured it earlier because then I'd have more data in trying to bring it down or keep it as low as possible. So over those 6 tests in 2025, average B2M is 1.58 milligrams per liter, which then again raises a question of what's optimal. And without going to the Patreon tier, the what's optimal for biomarkers tier, again, lower is generally better. If you want the actual numbers and you want to see the data that I used to derive that story, check it out. Also, avoiding an age-related increase. And this story is currently incomplete as I only have 1 year of data, so I can't evaluate if I'm resisting age-related change. But then it raises a question of what can I do to reduce B2M, as I'd like to go lower. For me, my interpretation of the published literature is that 1.58 milligrams per liter for B2M, while although not terribly high, isn't as low as I'd prefer it to be. So in terms of what I can do to potentially reduce it, I'm going to look at correlations for diet with B2M. And for those who are unfamiliar how I'm able to do that, since 2015, so for the past 10 plus years, I've weighed almost all of my food, more than 99%, with a food scale. I then enter those data into Chronometer, a diet tracking app. And quick shout out, if you want to use Chronometer, there's a discount link in the video's description. I then pull the Chronometer data into a spreadsheet, so the macros and micros and individual food amounts. So now each dietary period in between tests can be used for the ladder test. In other words, if there's a 50-day period in between blood testing, I can take the average dietary intake for those 50 days, and that lines up with the ladder blood test. So now every blood test has an average dietary intake. With enough blood tests, once I get to 3 blood tests, I can start looking at correlations. Now sure, there's going to be a lot of noise in the data after 3 blood tests, but as many of you know and have seen on this channel, I have now 60 plus blood tests for most clinical chemistry related biomarkers, kidney, liver, immune, etc. So I can look at correlations that can help drive me towards what's an optimal diet and even supplements. So using that approach, let's take a look at correlations for B2M over these 6 tests with diet to see what I could potentially do to bring it towards the lower end of my range. So this is the top portion of that table, and note that correlations for diet with biomarkers, for all biomarkers, not just B2M, with 30 other clinical chemistry biomarkers, and then I also look at correlations for diet with metabolomic data. So I have another 600 plus metabolites that are correlated with diet. So if you're interested in that, check us out on the correlations tier on Patreon. So for this table, we can see that the lowercase r is the correlation coefficient. And then on the right, we've got the p-value as a measure of statistical significance. And here I've used just less than 0.05 as the standard nominal threshold for statistical significance. I'm not using a false discovery rate, and if people are interested in why that's the case, just leave a comment and I'd be happy to describe my process for that in the comments under the video's description. So in terms of the correlations, we can see that there are 4 that meet that significance threshold. Cacao beans, and these are raw organic cacao beans, not nibs, which have a positive correlation, which I've labeled as red. That positive correlation suggests that when cacao intake is towards the higher end of my range, that's significantly correlated with higher levels of B2M. Note that I said correlation. This is not causation. I can't say anything about causation. I can get close to causation by either increasing or decreasing a given amount of food or nutrient based on these correlations. But again, these are correlations. I'm not presuming causation. On the other hand, inverse correlations, which suggest that higher levels of the food are related, may be related to lower levels of B2M, include almonds, lemon, and potatoes. So what do I do with this information? Well, I try to follow the correlations. If higher cacaos is related to higher levels of B2M, if I reduce it, that should lower it. Again, if correlation equals causation, the only way I can find out is by doing the experiment. So to test that, for the next test, I've removed cacao beans. Additionally, what about almonds? So the correlations only tell us whether they're increasing or decreasing, but they don't tell us about amount of food to follow a given correlation. So let's illustrate what the plot for B2M looks like versus almonds, which is what we'll see here. With B2M on the y-axis plotted against average daily almond intake that corresponds to each one of these blood tests. First, we can see that inverse correlation, and then based on extrapolation of the plot, if I want to bring B2M levels lower, I should aim for somewhere in the 20 to 25 gram of almond range, at least at a minimum, per day. So average almond intake, again, because I track diet, I know exactly how much I'm eating for every day. Average almond intake since test number 8, blood test number 8 in 2025, is currently 19 grams per day. And you could say, why not go higher? Why not just jack it up to 25, 30, whatever, 50 grams of almonds per day? Well, unfortunately in my data, not just almonds, but overall monounsaturated fat-containing foods are significantly correlated with higher levels of glucose, which is movement in the wrong direction. And you could say, how does that make any sense? MUFA are thought to be heart healthy. Why would that be positively correlated with glucose? I have no idea, but that's what the data shows in my case. Additionally, almonds are a rich source of oxalate, and potentially more importantly, their oxalate to calcium ratio, they have more oxalate than they do calcium, which suggests that oxalate from almonds will be absorbed and not excreted, as oxalate binds to calcium 1-to-1. So those are two main reasons why I haven't gone higher, as I have to modulate the amount of almonds that I'm consuming to keep oxalate levels relatively low and to keep my MUFA levels from going towards their highest level, which again, in my case, is significantly correlated with higher levels of glucose. So based on extrapolation of the average of 19 grams per day, currently since the last test, we'd expect that I should see B2M levels somewhere around 1.5 milligrams per liter, which still isn't as low as I'd like to get it to, but on the other hand, it may not be as high as my two highest tests, which you can see were greater than 1.6 milligrams per liter. But remember, this is just part of the story. I've also removed cacao beans. So if both of these foods are somehow involved in mechanisms that impact B2M, the combination of following these two correlations may allow for movement towards towards 1 or lower than 1.5. But there may be a sneaky food on this list that the correlations don't yet indicate how strong of an impact it may have on B2M, and that's strawberries. You can see that strawberries have a significant or close to significant, that p-value is 0.06, just outside of that threshold of p-value less than 0.05. So I've been eating a lot of strawberries, more than usual. In fact, since the last test, close to 3 pounds per day, which is up from around 2 pounds per day. Now, if strawberries are somehow involved in mechanisms that impact B2M, even if I follow the cacao bean and almond correlations, if those foods aren't actually involved in relatively high levels or low levels of B2M, and it's strawberries that are driving that, I may actually see higher levels of B2M for the next test. Nonetheless, this is data collection. That story is informative because the correlations for cacao and almonds will weaken, the correlation for strawberries will strengthen, and then with that in mind, that'll be more motivation to cut down on my strawberry intake. If B2M is a part of that story where high strawberry intake may be driving B2M higher, I'm going to have no choice but to cut down on strawberry intake, for sure, not from 3 pounds per day to something more moderate, 2 pounds per day, or even a little lower. It's tough for me because I love strawberries and they're satiating, and part of being on a calorie-restricted diet is eating a variety of foods that help keep me satiated, and strawberries are a key component of that. So will it work? Will B2M move lower for test number 1 in 2026? That test is scheduled for January 30th, and if you're watching this on YouTube, it may have been a month where I've actually done this blood test. If you want to see those data immediately after they came out, sometime in the first week of February, check us out on Patreon, where I also offer blood test consults and post at least twice per day in 4 other Patreon tiers. We've also got a whole bunch of discount and affiliate links that you can use to test yourself that help support the channel, including ultralabtest.com, which is where I go for the majority of my blood tests. But note that ultralabtest.com uses Quest Labs, which is pretty close to me and it's convenient. And that may not be convenient for others who are into blood testing like me. So I recently reached out to get another lab testing affiliate link, this time from Life Extension, which uses LabCorp. So if you have a Quest Lab or a LabCorp in your area and you're into blood testing like me and you'd like to help support the channel, if you use the affiliate links in the video's description, you would help out tremendously. At-home metabolomics, NAD testing with Ginfinity, Epigenetic testing with True Diagnostic. These are other affiliate links that are in the video's description. At-home blood testing with SciFox Health, which includes GrimAge. But again, I'd prefer to measure the actual biomarkers relative to the epigenetics. Maybe you disagree and you want the epigenetic test, as GrimAge is a very strong test consistently associated with risk of death for all causes in a multitude of studies. That too is in the video's description, affiliate link. Oral microbiome composition, diet tracking with chronometer, green tea, which I drink every day, the clearly filtered water filter, which I'm using every day too. Or if you'd like to support the channel, you can do that with the website Buy Me a Coffee. We've also got merch, including Data is my North Star, which I've got on here, Figuring Stuff Out is my jug, and the ConquerAging or Dietary logo. Link in the video's description. Thanks for watching. I hope that you enjoyed the video. Have a great day.